So today we're going to learn how to show the formation of covalent compounds. So in your homework, you are given the example of F2. So you will always be given either the formula or the name, because covalent compounds we can't figure out by crisscrossing necessarily how many of each that we're going to need. So my first step is to draw however many they tell me to draw. In this case, I'm told to draw two F's. So first step is that I'm going to draw the Lewis dot structures for all of the different elements that I am told to draw. All right. So I'm going to draw two F. Oops. And since fluorine is in group 7A, we are going to draw 7 electrons around each fluorine. Now, just to make my life easy, I'm going to make sure that the two single dots are facing each other. And you'll see why in a minute. All right, so if you notice, each F needs one extra electron. So instead of giving an electron to one, because then one would be happy and one would not be happy, we're going to see that this 2 electrons here will be shared amongst both fluorines. So my second step is that I am actually going to circle the electrons that will be shared. So what's going to happen is each fluorine is going to share that one pair, thus giving each fluorine an octet. Now, it's not a complete octet, all right, because they are sharing. It's not a transfer like an ionic bond. Now, lastly, what I'm going to do is I am going to replace the circled electrons with a line. And each line that we draw represents a pair of electrons being shared. And like before, I'm also going to have to draw the other electrons around each fluorine that are not involved in the bonding. Now, each of these pairs actually has a special name. They're called the lone pair electrons. And remember that this dot in the middle, that represents 2 electrons being shared between the 2 fluorines. Alternatively, you could also draw the 2 shared dots between them like that. I favor the line, but ultimately it is up to you. Either answer is an acceptable answer. All right, so now we're going to take a look at another example. So here we're going to try oxygen, O2. So remember, oxygen does not exist by itself. So take a minute and draw out both oxygens and see if you could see where they're going to be bonding to one another. All right, at this point you might be saying to yourself, but something's a little different here. So I'm going to draw both oxygens. I'm going to draw the electrons around each. Oxygen is in group 6A, so each oxygen is going to get 6 electrons. Now, they have to hook together at least once. And you might have done this in your notebook. Now, what about these electrons here? All right, molecules do not like to have single electrons hanging around. They want to be able to share because otherwise they will not have that octet. All right, as it stands, we don't have enough electrons. So what I'm actually going to do is I'm going to circle that next pair, just like that. Molecules are capable of bonding more than one time to one another. So in this case, since we're sharing 2 pairs of electrons, we call this a double bond. In the previous example, since we only shared 1 pair of electrons, we call that a single bond. So now let me go ahead and replace the 2 shared pairs with lines between those oxygens. And then I'm just going to put on the lone pair electrons that are not being used. So I'll give you a little bit of time. Using what you've learned in the last 2 slides, try N2. All right, so we're going to be drawing 2 different nitrogens. The number at the bottom tells you exactly how many you need to draw. Alright, so you should have something that looks like this. Again, I'm going to put those electrons, those single electrons, facing towards each other to make my life easier. Because otherwise you have loops all over the place and it might get a little confusing. So here you might have noticed that there are 3 electrons that are single, that are able to bond. So I'm going to go ahead and I'm going to circle them once. And now if you notice, there are 2 other pairs of electrons, or 2 other single electrons, that each of them can bond to each other with. And that's okay. Turns out that these molecules can actually share up to 3 pairs of electrons with each other. So these atoms in these covalent bonds can share up to 3 pairs of electrons. And hopefully you guessed the name of that. It's called a triple bond. So again, now I'm going to go ahead and replace those 3 circled pairs of electrons with lines between them, representing that triple bond between the 2 nitrogens. And now I have drawn out N2. So now go ahead and try H2O, dihydrogen monoxide. Cannot live without it. Now remember, since they're all written together here, we have to make sure that they're all bonded together at least once. So I'm going to give you a couple seconds, all right, to try and draw this out. Remember, they all have to bond together. All right, so remember, we're going to have to draw out 2 hydrogens and 1 oxygen. And by drawing it like this, I'm hoping you could see where they're going to bond to one another. Some might be tempted to do this. The problem with that is that hydrogen is bonded together, but oxygen is off by itself. I cannot have that happen where I have 2 single electrons left over. Everything has to be connected together. Hydrogen's only capable of making 1 bond, and once it makes that 1 bond, it's over. All right. Oops. So instead, if you might have noticed, we're going to bond everything to that oxygen. It works out perfectly. So each hydrogen is single bonded to the oxygen. Now, oxygen has a special name because everything is bonding to it. It's called a central atom. And the central atom is the atom not only that everything is bonded to, but the way to tell what element will be the central atom, it is the atom that will make the most bonds. So since oxygen has 2 single electrons, it will make the most bonds. Thus, it's our central atom. So now I'm going to go ahead and replace, again, those circled pairs with lines. And not forgetting to still put my lone pair electrons on my oxygen. So your water molecule should look something like that. If you have to turn your head to see it, that's fine. As long as if you can turn your head, it looks the same on your page, you got it right. So now try drawing out CO2, remembering what we did with water and also with some of the other molecules before that. All right, so I'll give you a minute to draw those out. Remember your central atom. You have to figure out which one, carbon or oxygen, which one is going to make the most bonds. Your answer in the end should fit together kind of like a jigsaw puzzle. There shouldn't be any single electrons left over at this point. All right. So you might have noticed that carbon is in group 4A and thus has 4 electrons. And those 4 electrons, if we remember our rules about drawing out our Lewis dot structures, are all single electrons. So carbon is able to make 4 bonds. So oxygen, as we saw before, is only capable of making 2 bonds. So what I'm going to want to do is to make, again, things less confusing, I'm going to draw an oxygen on either side. Molecules like to be as symmetrical as possible. All right. Also, if you draw them all in a line, it gets a little confusing to see where they all attach. So I'm going to draw my oxygens on both sides. Now, everything has to attach to the central atom at least once. So I'm going to go ahead and circle those oxygens to my carbon. So everything is attached now at least once to my central atom, carbon. But if you might have noticed, I still have single electrons hanging around, and I can't have that. Right now, some of you might have realized that I can now circle those again to my carbon, and that's fine. Remember, between each of the two atoms, I can have up to 3 pairs of electrons being shared. So it turns out carbon is double bonded to each oxygen. So now I'm going to go ahead and replace those with lines. All right, and thus I have now drawn out CO2. All right, so here we see an example of where we have more than one central atom. I have 2 carbons and 6 hydrogens. We know carbon is going to be our central atom because we saw before that carbon can make 4 bonds, whereas each hydrogen can only make 1. Now, if you have more than one central atom, you're going to find that the central atoms have to be bonded together at least one time. So I'm going to go ahead and I'm going to draw my carbons. And I'm already just going to bond them together the one time. It might be that you have to bond them together more than once, but we're not going to look at that until the end. Now, to make my life easier, I'm going to draw those hydrogens around the 2 carbons. This is going to help me see where they're supposed to attach. It might look a little crazy right now, but once you start circling those electrons, it'll start to make a little more sense. Alright, so now I'm going to go ahead and bond those hydrogens to the carbon. And if you notice, again, symmetry. Same thing on this side. So now I'm going to go ahead and again replace those circled dots with lines between them. So I have carbon bonded to carbon, and then I have my hydrogens, 3 hydrogens attached to each carbon. And that would be my final answer. And that's ethane, we're going to find out. Alright, so if you take out your new packet, we're going to try some practice problems. Alright, so you're going to try them on your own. So if you open up to near the middle of your packet, you're going to see a worksheet that looks like this. Alright, what I want you to work on right now are these problems right here. Alright, number 4, you're going to have to think about it a little bit. Alright, but the others are just like the examples that we just went over. Alright, so now work on those, and whatever you don't finish, alright, is going to be homework. Alright guys, have a great day, and you could do this.